There we go. So now I'm recording. So that will always be, and I'll post that on Canvas as well. So thank you guys for all that feedback in terms of what I had asked, kind of asked you about what courses when you had taken certain courses, and also just what your concerns are, just in general. So I mean, I guess we're sort of now in some sort of a new normal. I mean, it felt weird. It continues to feel quite weird, like having class without actually going to class. So I would encourage you, to just like I do, like I set about 3 alarms, so that I just don't miss this. I would be incredibly embarrassed if I were to do that. But it just feels so weird. I mean, the flow and the feel is so different, in trying to get here. So like I said, this should normally we're going to be together about an hour, and then I've got more content for you, asynchronous content. So I'm going to keep referencing that. That'll happen again today. Um, so uh, next week, however, on Tuesday, we'll start doing some group meetings. So we'll talk about that more. So anyways, just, you don't think about it from 4 to 6, think about it more from 4 to 5. And that'll kind of get us through. I would use, and a lot of you did as well, that, I mean, we're in this sort of unsettling way to describe what we're doing. It's just completely unsettled. It's all brand new. Hopefully it won't keep lasting, but some of you had mentioned, and I am aware of, you should say your be a varying range of ability, or even, perhaps past experience, in quote structures. I will do the best I can to really try and always tie it, and so that it is not just some sort of standalone thing. That it's not just structures that is separate from architecture. So I will keep trying to do that. The asynchronous stuff is meant to be, is the supplemental information, and I am also, I will, like I said, I will be available much anywhere outside of that as well. I've got you set up. We'll get to us for 8 groups, as we go do our first project. So that'll come up as we work through today's material. I'm going to put a picture here for you. So this is also on the Canvas page. So I've got a picture of this and a link to a website, Academia. You might be familiar with it or not, but I'm going to assign kind of chapter 1 out of this. It's looking at structure and nature, which I'm sure you have done before, but this would probably be a time that we'll go back and look at it again, and something to, as we have, maybe a little bit more time to be contemplative. We'll go ahead and read that. And this is a free book. At least I got it for free. So I'm going to see if we can get you guys to get it for free as well. And so this is what we're going to take a look at: structures in nature. And so it's kind of easy reading, but we'll do that. And I think I'll start something on the discussion board about it. So we'll get that installed if we can get it on Academia. And so I'll show you that. Actually, the link is on Canvas. So, all right, give me just a second here. All right, let's do this. So this is what we've got on the table today. So we'll have a little bit of information dissemination, so a little bit of lecture. Um, that'll be focusing on vertical load path. We'll also talk about lateral load path. Then go look at what I'm going to assign you for homework one, and then also project one. And so that'll be what we have. I will have then. I've got about 45 minutes worth of recorded lecture. Um, I would say that by doing that also, although it might just be 45 minutes, the way I'm able to deliver that, if I were to do it in real time, it would take longer than that, because I'm able to stop and sort of restart the tape again. So maybe just kind of keep that in mind. I then just go into load path, some tributary area, and then also just more on structural systems. So really what we're trying to do is get you prepared to do homework one and then project one. So I think that's what we'll focus on here, and see if I can get you to hopefully a good spot here. So I'm going to share my screen again, and I'm actually going to move away from my camera. Again, if you have anything, you can raise your hand or type something in the chat as well. A little bit tougher for me to see it. I'll come over and check sort of periodically. So this will probably take about 20-25 minutes, if I had to put a number on it. Why can't I see that? Ah, there it is. There's the chat. Okay, so I'll keep my eye on that. So, all right, integrating structure. Of course, that's really the focus of the class. So, I mean, the importance of structure in terms of all the different elements that go into design. And there's obviously competing elements that are working in terms of how you're developing what's going on with a whole project. But there's really some realities about structure, and it is not the most important thing, but it has certain different implications. And so I will keep alluding to those as we go through this here. But, factually, if it resists loads imparted to the structure. And you could say resist, I mean, really what it is it transfers loads ultimately, and we would say successfully, to the foundation. And that's really where those loads need to get to. So they think about it in terms of resisting, as in they're able to withstand them. And where do those loads come from? Right? And two major components here. We've got vertical loads, right? And then lateral loads. So homework one, project one, focus on this, but you will still deal with that. That won't be something we just don't pay attention to at all. And you'd be aware of, right, those vertical loads: dead load, live load, and from a type, right, a uniform load. There could be something that was triangular. You might see that with some soil pressure, also some wind loading, and also, but we end up really using quite a bit of point loads as well. So lateral loads coming from wind, soil, and seismic. And really it's going to be seismic and wind that we're aware of. And vertical dead loads, mostly coming from the material weight of the building, and then the live load coming from the occupancy expected. Wind, mostly being the fact that you can't control where something is going to be occurring at, like, or where the site is. It's really a major function of the profile and what the building looks like. in its profile, because wind is defined as a pressure, where that pressure is going to be in a force over an area. So the way we end up getting force is that profile, which has units of area, is going to allow us to create the forces that are imparted to the structure. Seismic loads, right? The main issue with seismic loads isn't the fact that the ground's going to shake, but the fact that the seismic load is going to be proportional to the mass. And so the mass times velocity is the linear momentum. So the change in linear momentum, slightly, is the mass times acceleration. So the mass is the quantity that resists the change in linear momentum. So that mass is what that building wants to stay in one spot. And as the ground moves, then it creates an inertial force or an inertial load. So when you have a building that has high mass, then you end up with high seismic forces, keeping in mind the fact that you can't really control where the site is, and there are all the seismic issues based on location as well. And then also there would be impact loadings that we won't really get into a whole lot. But so from that first project that you've got, is we are going to create load paths and then make sure they are well designed. So in a lot of, like in homework one, for instance, right, a lot of this you'll be told, you'll be given grid spacing, you'll be asked to do something very specific. But in your projects, it's much more open-ended. And so I want to get you thinking in that direction, in terms of you need to create a grid, and you need to create some spacing, you need to create some spacing. And so the loads that are going to show up, a lot of times we will just end up defining something. This is going to be based on the material choice in your occupancy. And then there are other loads that, right, they may never occur. Those wind loads, those seismic loads, you have to design for them. They may only occur once, but once is quite enough. And these loads, right, get into life safety issues for occupants. So all those loads need to be pathed to the ground. And what I would just say on that is they actually need to be pathed, not sort of hypothetically, not, well, it just sort of like, it needs to be thought out. And so that's what we will make sure that we're thinking about, is how do those gravity loads, how do they actually get to the ground? And then also the lateral load. So we'll continue to expand on that. And so big picture considerations, all right? Safety, I've already said this a couple times, but life, safety. And so not only life in terms of life and death, but also occupant injuries. So I would sort of make the case about, if the heating or the ventilation went out in a building, nobody would really be in danger immediately of their life or being injured. They'd be able to leave. Right? The issue with structural design is that can be an immediate occurrence that can show up very quickly without notice. So that's where the issue of safety is much more sudden. Obviously, there's always issues with cost, but I would define value, right, is the comparison of what you get for what you pay for. So obviously there's a cost, but which is more of a dollar issue, but value deals with what you get for what you pay for. And so that's a component. Compatibility, right? Integrated in terms of the structure, right? Oops, is it integrated? With the mechanical, the electrical, right? The building envelope, we get into cladding a little bit. The site, right? The location, that'll come up again. So is it compatible with all those other design issues? And then finally, flexibility. And so this would be about the lifespan of the building. And in terms of changing function and site context. So not only the function of the building, but if other things were to show up on the site in the future. So all that comes in with the structural design issues. So selection. So I'm going to bring just a couple words in here about what we ultimately want to have happen. We want a system that has integrity, meaning it has completeness. And so it's not a little here, a little there, but it has sort of an integral design, an integral completeness. Right? It deals with economy. And so that would also deal with the ability of something to be built. Gets down here to constructability, which would be both based on the location of the site and sort of the local builders, what they can actually build. And we want this thing to have good continuity, right? Load path, the system. And then another thing is redundancy. And so really that is best defined that we want local failures, right? Or component failures. We want them to not create global instabilities. And so that comes to the issue of, we've got a structural system. I have a single shear wall. And so, or should we have multiple shear walls? And that multiplicity, redundancy is something that is important in design for life safety. And that way, if one element or one component fails, the entire integrity of the entire structural system does not become unstable and therefore have a collapse. So let's just kind of work down here. Right, span requirements. This will come in quite a bit on that first project. Right, what are the span requirements? What are the functional needs? How much footprint? Right, you're going to need to make sure that you've got a project that has dimensions, not just sort of hand waving, but we've got, this is the space. And obviously that's what comes up all over in that handout, in the handout that we worked through a little bit last time. The depth requirements deal with what the span is. And then also internal, external, this would be with cantilevers or overhangs that could show up. Right? There's obviously a cost associated cost and value, right? The constructability, how is it buildable? Not just because the site might be challenging, but also what might be available in the local marketplace. Safety, right? Again, the safety of the occupants, and understanding redundancy, flexibility. Right? Another one that is just story height. This deals with the depth that's required for the elements. And then also the aesthetics is something that needs to be a part of what's gone. I think we want to stay away from the thought that then, this engineering is not, it has no ability to be beautiful or should be covered up. It can obviously definitely be exposed. And so kind of moving with structural integrity. So, I've talked about the issue with, the design priority. And so all those things, that you see there, right? They vie for design, time, and attention. And so, dealing with the importance level, right? Dealing with the size, dealing with the span, right? The things that are desired within the structure itself, right? That can push structure a little bit higher, or definitely can push it to earlier in the process. Something that we don't want to ignore for too long, or you may not be able to solve an issue or be able to build it. So it's something that vies for the attention, and really the reason why is that these things really can't be ignored. The issue of where this thing is located, right? That affects the wind, the seismic, right, and those forces, right? The site conditions, we don't really get into this a huge amount, but this seismic calculation goes down to local factors, like the local soil, and you end up with soil structure interaction. The topography of the site, if it's a hill site or a flat site, the local construction, the space requirements based on what's needed inside, and then this load path need that needs to be satisfied. There are rules, there are basic foundational principles that need to be dealt with. Structural systems before component design, before we can get to designing in a component, we need to make sure we've got a structural system. So a lot of the homeworks, like homework 1, you're told to use steel or concrete. On project 1, you'll be able to decide what you want to use. So just kind of bringing into focus what it is, right, that you'll end up doing in this class, right? How you'll end up doing it, you will end up creating study models, your wood cardboard combination. You can end up laying out these things. You'll be doing it. You'll be making the decision where the column grids are, right? Therefore, based on span, then what your girder depths need to be, right? What the lateral system, what the distribution is, and what type of system you use. If you're going to use shear walls, brace frame, moment frame, the vertical coordination, right, as loads flow through, and then the same thing with the lateral system. So that's really what this will at first have you be doing is trying to take your project, your architecture project, and fit, make sure structure is smartly brought in. Right? You'll end up with narrative calculations, justifying calculations. So you'll have to do some amount of that. It won't be too heavy there, but you'll need to be able, you'll be able to manage that. Something else that will keep coming up is just the use of units. I'm going to make sure we do that. You'll end up with schematic structural plans, and then later on in the class we'll end up with some detail work as to how we're going to hold some of that cladding on the building. So then the last one here, and then we'll take just a little bit of a break, this idea of global versus local structural issues. And so when we get to this project one, you're going to deal with global issues first. And then once we've got our global issues worked out, then we get down to the local, or the, a little sticky here, the component level. And so you'll be using rules of thumb for sizing, right? Up here on the global issues, right? Using the whole building, right? Considering the building as a whole, right? Vertical loads, right, need to be dealt with, right, from a global system. Span requirements, dead load, live load, all right, will need to be set out, right? So when you make your material selection, that then triggers what you're going to use for the dead load. When you have an occupancy, that then triggers the live load issues. And I'll keep in mind that lateral loads, I think, are even harder to appreciate. I mean, certainly they're harder to see or feel. Generally want to avoid, always better to avoid strong wind or seismic. But these are things that may never happen, hopefully. But those deal with, you know, the stability and life safety issues. So that's why the completeness of load path is extremely important as we get to the designing of some of the elements that we'll get to, but we will make sure that we have a complete and a integral, or an integrated complete system for both vertical and lateral loads. All right, so I'm gonna let's do this. So take just about a 3-minute break. And so we'll go at about 4:45. So just a quick 3-minute break. I'm just gonna get up and get a quick drink of water. And then we'll go through homework 1 and project 1. All right, we will take a look at, it's on Canvas as well, but I will just share the screen here. So I'm gonna just talk through this with you. So homework one, you want to kind of think of homeworks as being, I would say, a little bit of exercise wise. They'll always be due before the projects. So what I did is we've got a little bit here. I'm trying, I've actually laid out, this problem came from one that was a lot longer, and all I've done is actually I've told you what the final answer is and given you some values for other loads. So I've told you how much the ceiling is, right? The mechanical, which isn't shown, and then a miscellaneous. And so all I'm trying to get you to do is right here is deal with the slab and the beam right here. So I kind of lay, one moment. I got a hand, just a moment.
I didn't see the homework one in Canvas yet.
Ah, okay. It will be there then right after. Oh, actually, you know what? I know what I did. I will do it. I will do it right after. You know what? Why don't I just put it?
Okay.
You know, I can do it right now. You know, I probably don't want to do this in front of you. It might look a little weird. So I will do that. I will do it right afterwards. Thank you.
Okay, thank you.
Yes. Thank you. All right, let me get this away here. All right. So you'll end up, really what I'm trying to get you to do is just go from pounds per cubic foot to end up getting to pounds per square foot. And so you just got to have to deal with the dimensions and the thicknesses. And so this one deals with, this is a 16 by 24. And I write this out here, is that 24 goes from the top of the slab all the way down to the bottom of the beam. So that one's not meant to be, that one should be kind of a quick one, but I'm forcing you to kind of get into the units. And the reason why is that's going to continuously come up when we go from pounds per square foot to pounds per lineal foot. That'll show up on a beam. Number 2 and 3, this is, shoot. Anyways, I will fix that as well. Let's just say problems 2 and 3. So what I'm going to do is, this really mimics what I did in the asynchronous material, where I did some beam sizing, both for steel and for concrete. So what I'm going to do is just kind of go ahead here. So it's a 3-story, and the roof and the 3rd floor have plans like this. This would be the 2nd floor framing. So the only thing to highlight, and I make good note of it, is that those columns, they do not go all the way down to the bottom. So on the bottom floor, you've got a huge open space. And so you end up with big girder loads down there. So just to think about load flow as you work your way down the structure. So the transfer girder will be quite large on both of those plans. So something to just keep in mind as to what I've got you trying to think about. And this really you'll use LRFD. So that'll be your load combination. And so I also give the loads right here, the dead load and live load that shows up on each floor. And for concrete, we'll just take the dead load to 150 pounds per square foot. So we're already in an area load here. So that should get you, I think this is just meant to get you going in the direction for the project. So let me get that project up here. A little bit smaller. All right, now I've created groups, and we'll go over that in just a minute. And so you'll end up in groups of about three or four, and we'll talk through that. So let me just hold on here for just a minute. So this is about a 2-week project, and so we're going to develop the gravity framing for hopefully for a studio project if possible. So we might not be able to do that, or like I said, we'll be able to work through that here. So we'll have some project information, and then you'll end up doing this in a couple of different, in some iterations. And so you'll end up with some framing calculations, and then also some structural plans and you'll end up just using that class 1 handout with the load and design, dealing with span and depth calculations. And so you'll end up either using a project in your studio, or in your group. What you'll end up doing, you could just make a project up in this regard. So and from a creativity point of view, so I don't want a box. I'm looking for something that is much more creative. Generally in this class, at this point, we would coordinate heavily with your design studio. Because we're in so many different design studios, it's really impossible to kind of do that logistically. So what we're going to end up doing is this become a little more apparent in terms of consultation. So next Tuesday will be the first consultation that we'll end up doing with your group, and we'll sort of do it group at a time. And so what you're going to do is you'll have a concept. I really don't, it's okay in terms of where you might get this project from. You're going to focus on, right, the gravity load carrying system that you're going to develop based on spans and materials. And then you're also going to need to have the lateral system, I'm going to say, accounted for. So it's not just going to be gravity only, but we are going to have lateral systems in there. That won't be the main focus, but we'll end up with some sort of a lateral system in there, and that'll become apparent when we do our next Tuesday consultations. You're going to build a model, and so that model would be constructed at scale size. Ideally just with simple dowels at this point for columns and girders. You can use any sort of construction that you want to use, but those elements will be wood. And then when we've got for diaphragms, for beams, joists, you'll just draw those on the diaphragms, which will be made out of cardboard. So I'm not really sure exactly. We'll discover a little bit as to how we'll be able to hold up a model, share it within a group. I would think you only need to have one per group. So I realize that puts you guys a little, you can't get together to build it. But we'll kind of see how this works out. And give me just a second here. So this is on Polylearn, or on Canvas as well. When I put up the page for today, it's not up yet, but I'll put up the page for today. So I've got you grouped in numbers, in letters. So and what the reason why I'm going to post this is that way you'll be able to contact each other by email. I also have your username right there. So you'll be able to come together as a group and um, start this project. And well, then on Monday, I'll reach out to each group and give you a time. But basically, it's going to be, starting with A is going to be like at 4 to 4:15, and we'll kind of go every 15 minutes. So just to give you a heads up as to how that'll kind of play out next Tuesday. And so what I'm going to be interested in is talking through your model and your concept in terms of your system that you've created, your gravity load system. It doesn't have to be, it won't be a complete analysis or design. You're more than welcome to take a studio project, a design studio project, and coordinate or integrate structure into it. Now I know I've got you like in groups of 3 or 4. So I am completely fine with using that time. If you had a question about a project that you were doing in your studio, that would be fine. But collectively, in the end, your group is going to have one thing that they're going to submit. Like you're going to end up with one submittal project. So it might be something somebody's doing in studio. It might not be, but that's what you'll end up, as this thing unfolds, you'll end up with one submittal by group. Won't be able to submit a model, but I'll end up having you take pictures or take a video of it with what you will submit drawing wise and calculation wise. So that model building will be a piece of it. That will be a piece that I will end up using in our meeting next week when we get to something on next Tuesday. So let me go back here for a second. So in terms of what, this is focused mostly on framing, on spanning, and then really, but it's an open, this might be the first time that this is open in terms of what material and how you're going to span and what your spaces look like. And so that's what puts in your lap the decisions of what material or even how you're going to end up laying out your grid system and how big what that space looks like. So we want to make sure that elements and that we've got stability and continuity, right? And the load path. And you won't have any calculations yet for next week. But your concept, your paths need to be thought out and developed. And I'm more than happy to talk about more than one concept in a group. If you wanted to throw around different things, like I said, if people are working on different projects, and then all it is that in the end it'll end up being one project that you guys submit. So I hope that makes some sense. I'm gonna unmute. Actually, hold on a second. Give me 1 second here. Maybe about one more minute. Yeah, there we go. Just a minute here. All right, let me share my screen. All right, so Yiling had brought up that, so I've now posted this, or I've published them. Sorry, so they'll be under assignments for homework 1 and project 1. When this finishes, I'll end up with another page from class 2. I'll show it to you. I've started it. And so this will give us a link. There's that. Oh, I forgot to mention that. Oh, that's why it's on there. You are more than welcome to call me Andy, Andrew. You can call me Dr. Guider. I will probably out of habit sign emails that way. I haven't gone by Andy or Andrew, but you are more than welcome to do that. I will probably get used to that pretty quickly. So that's completely fine. There's that book. There's the link right there. So I have to post this still. And there's those groups. And then I will link also, I've got, I will have about 3 videos, actually 2 videos that'll be linked to, that'll be asynchronous, dealing with structural systems, the different types of structural systems, and everything, and hopefully things that would get you moving and thinking such that you can be successful on homework 1 and project 1. So just looking ahead, homework 1 will be due next Thursday. Anytime it's due, it'll be at 8 p.m. that day. Project 1 will be the week after as well. All right, I'm gonna unmute. If you wanted to show me your faces, you're more than welcome to. So I'll kind of free for all it here.
I had a question about the consultation for next Tuesday.
Yes.
So we need to have a physical model by next Tuesday, is that correct?
Yes,
Okay, is there a specific scale you want us to build at, or?
No, actually just whatever scale works for you, I would say.
All right.
Something that's the only thing I would say is that I'm hoping to be able to have you hold it up. If not, this might be something as we develop this, then it might be something you just take pictures of, or spin a video of. But if you could, something like that would hold up, like you could hold it up in front of your face and we could kind of deal with it. So
Okay.
if you have a large project, then it's fine just to deal with a small piece of it, or a sub piece of it, if that makes sense. If you've got something large, it'd be just fine to deal with something that would be a piece of it.
Okay.
Okay.
And so basically the way it's set up, it seems like one person has to take on the task of building the whole model, even though we have groups, just because of.
So I don't anticipate, the model is a working model. It's not meant to be, it's not a, it is like, one sec. So that's a good question. Like I'm thinking like model that deals with like that thing, right? Cardboard
just
and sticks.
Relatively rough, like.
Yes.
It doesn't have to be. Okay.
That would be my goal. That it would be more. It would be rough model, but thorough is what. So as working on it with a group, you would be able to, if you were the one building it, you would do it as you're working on it, not an exact Not many X-Acto knives being used too much.
All right. So like, I think, so for this working model, you'd want us to have at least the dimensions like
Yes.
for each floor plate and the height, ceiling, floor to ceiling heights and stuff, things like that. But it doesn't have to be super
Yeah.
specific in terms of where our lateral bracing is and things like that.
No, not specific, but we've got to start moving in that direction.
Okay. Okay.
Yeah, I would say it's more you should, by next week, you should have an idea. You need your dimensions because of then you need to know what your minimum depths are. And so there's your floor height or what your open space is, and then what your floor dimensions are. So that's what we should be able to move pretty well in that direction.
All right.
And where you're going to put your lateral system, yeah, we shouldn't have not thought about that yet.
Okay.
Okay. And what I also want to encourage you all to do is, as you go through this, like, I want you to be comfortable and safe to be able to explore things as best we can, on Zoom like this, but that it's safe. Like, it's completely fine. That, hey, we haven't thought about this yet, or, well, we did this and I don't know why we did it, but we're just thinking, that's completely fine. That's completely fine. The hard part we're going to get is we're not doing that at all. So that's what that first consultation will get you guys. I just want to see that you guys have started to go through that process and made some decisions. And you may not have known why, or I'm not quite exactly sure. That's what I'm there to help you with. That's what I want to help you with. But I can't show up and do the project for you or with you. But that's what I think we have to be able to do. And I know we can do that. So does that, I think, help us? All right. So it's going to take me about 5 minutes. I'll have that page up with the asynchronous material as well. Okay. All right, guys. Good luck. Have a good weekend. I mean, the first weekend of the quarter is supposed to be a party. I don't think this one will be. But be safe. Okay.
Professor.
I have a question. Do we assign group yet? Do we?
Yeah, I did, and it's going to be on, just a second. It'll be on the page. Sorry. See if I can share it. It'll be on. So here it is. You don't have to screenshot this. I will put that on the page I post in about 5 minutes. So it'll have everybody's group there by letter.
Okay.
Okay. So it's by design. It's by studio, but I don't know if that helps or not. It's somewhat by studio, I guess. Somewhat. Okay. So this will be up in about 5 minutes, and you've got a chance to get with your group. Okay.
Thank you.
Yes, you're welcome.
Sir?
All right.
Can I ask a quick question?
Oh, please. Yep.
Can you hear me?
Yes.
So I'm assuming for each project we'll have a model to build, and would it be we would continually build on one model each time, or would we have to rebuild a new model for each project?
I would think it would end up being a different model for each project.
Okay.
I know that in general, like, this is where we're it's a little bit different in here due to the fact that we're in so many different studios. So it's not going to be as possible to sort of coordinate it over the whole quarter. If something, I guess what I'm saying is, the way that I've set it up, it very well might be a different model each project. There's 3 of them. You might not have to do that, or you might have a project that doesn't that allows you to use it. It's sort of open-ended. It's kind of unknown as to exactly how it'll play out. So I don't know if that, but I think it's kind of a one and done on the model thing.
Right. I guess just then if we're just building off of one model, that would just mean that the same person would be building the model each time throughout the quarter.
Say that one more time. I lost you just for a second there. Sorry.
Sorry. So then if that was the case for each project, that would mean that the same person would be building the model each time for each project. So I don't know if that would be an issue or if that's okay if we sort of just dedicate one group member to build the model each time, or if you'd like us to like switch
or something. So I think what we'll end up doing, like the model that we'll use, or the structural model, it's really meant to be a means to be able to create the drawings. It's not as much the end state. It's more of the working model in the intermediate stages, or in the development of it. So I think it could be done by whoever wants to do it. I don't see that as I know it's weird being at distance like that, but what we're going to end up doing is sort of taking a little bit of the focus off the model. Once we know what we're doing, once we've got it, then it's going to be more drawing based, plan based, less model based. So it's really something we're doing at the beginning of the project, more so than at the end having a nice model. It's got to be a little different. It's going to be more drawing based.
Okay.
Is that kind of?
Yeah, that's good. Thank you.
I also have, what do you think of the option of building the model in a 3D program, perhaps like modeling in Rhino or SketchUp or something like that?
That would be completely fine as well. Yeah. Yeah.
Okay.
They give you kind of creativity of how you want to do it. Yeah, that would be fine. That would be fine.
Okay. Thank you.
Okay. All right. Have a good one. Thank you, guys.
Thank you.
Yep. Bye-bye. Thanks, Connor.
Thank you.